his speech from Advanced Communication Manual. It's called a fact-finding report from the manual Speaking to Inform. To help him do this project, all of us need to support him. We will have to imagine that we are part of a management of a huge petroleum company. I really wish I was. Okay, and there have been a series of fires at petrol station, and as the company's technical expert, he will present his fact-finding report about the problems. And to evaluate his project, we have our dynamic, or I should say a dynamite, our distinguished Toastmaster, Sunil Kottarathil.
Toastmaster of the day, fellow Toastmasters, good afternoon.
Good afternoon.
Objectives for this project, a fact-finding report from Speaking to Inform Advanced Manual is prepare a report on a situation, event, or problem of interest to the audience. Deliver sufficient factual information in your report so the audience can make valid conclusions or a sound decision. Answer questions from the audience. Time 5 to 7 minutes for the speech and then 2 to 3 minutes for the question and answer section. Right. Thank you.
Am I audible?
Yes.
Madam Chief Executive Officer and members of the senior management, it's my privilege today to present the findings of my investigation. Thank you for having had the confidence in taking me for this role to find out what the cause was for those repeated fires that we have been witnessing in all our petrol stations. And I believe I have the root cause for this, and which I'm going to present to you right now. Let's take a quick look, because I know some of the management persons here are from not technical branches. Let's have a quick look at what happens at the filling station when a road tanker is brought to the station to offload the product. Now, we have the road tanker here on the left, and we have an underground storage tank which is buried under the ground. This is where all the petrol is kept. And the hose is connected, and the petrol flows by gravity into this underground storage tank. Now, there is a fill pipe here with holes that you will see, and I'll explain more about these holes in a short while. Now, let's see how it happens. When the hose is connected, and the filling operation has started, and as you can see, the underground tank is slowly getting filled up. While it is getting filled up, this is petrol, remember, and the vapor, the petrol vapor is constantly getting pushed out through this opening into a distant vent into the sky. So this is the normal operation in all filling stations, and part of this design has come from a legacy design of the old filling stations. Of course, today we have a very modern, flashy filling station. Let's look at the second aspect of what causes fire. As most of you know, there are three major elements, which go to make any fire. The first is fuel, something combustible, something flammable should be present. The second is the necessity for oxygen. And the third is that energy, that spark, which will create the ignition. Now, we have examined various causes, and among them, we have found that we cannot eliminate the fuel entirely, because that's our business. And the energy part, the spark, from where does that spark come? This spark can, of course, it could be someone smoking a cigarette, it could be someone using a mobile, it could be electrostatic discharge, the static electricity which we all talk about. We went through all of this, and finally we discovered that the only possibility of the source of ignition has to be static electricity. Now, static electricity is something which is very hard to locate. You don't know the source, and it's very hard to eliminate. It's not an easy thing at all. So having done all of this, we decided to do a little bit of more fundamental research as to what are the possibilities. Now let's look at the same image again. Now it's in reverse. Now the petrol is getting filled into different cars and the level is slowly going down. As it goes down, what happens is these holes in this pipe through which the petrol was flowing out is now getting exposed. So what happens is that the petrol vapor here, which is slightly charged, you see this pipe here is actually a PVC pipe. And when petrol flows through PVC, it generates some amount of static electricity and the vapor inside here is charged. Now what happens is, because of these holes at the end of the process, at the end of the process, the vapor tends to escape through these holes and go back up to the pipe directly. This is what we expect is happening. Now the question comes, if that is the case, these charged petrol particles, when it reaches here, because of the static electricity, it creates a spark. It creates a spark and catches fire. The question comes, why it is not happening every time at every filling station all the time? In the same filling station it happens, sometimes it doesn't happen some other time. I have an answer for that. If you look at the next slide, that PVC pipe, initially when it is laid, it is perfectly in slope. But over a period of time, there's an amount of sagging, which I have confirmed through physical excavation. So what happens is, at the end of the fill, there's a certain amount of petrol which is blocking the passage. And this prevents the fuel from coming up and causing a fire incident. After some time, this evaporates from here, and then suddenly the vapor comes. So it depends on the various factors. Certain times the vapor is able to come back at this filling point. Now I'll take you off for one moment to what we have in our toilets. Have you ever wondered why in our toilets there's always some amount of water after every flush? It's something very simple. It's called a liquid seal. It prevents vapor from outside flowing back inside and creating a stink. Similarly, if I go back to my previous slide, there should have been a liquid seal between this tank and this pond. And that liquid seal is broken because of the provision of these holes. These holes were totally unnecessary, and this is a carry back from the old design, where the petrol pumps were small and these lines were very short. In fact, some of the filling stations in those days, the dispenser was sitting directly on top of the tank. So in those days, even if these holes were there was no problem. But today in our filling stations, the tank is far away from the offloading point and we have these sags, and today we have this instance when we lose the liquid seal. So my investigations convinced me that the reason for the fires that we have been haunted with, in fact over the last 2 years we had more than 50 fires. These fires had been caused because of the liquid seal loss. The conclusion therefore is that the legacy design has allowed for the possibility of using liquid seal, and the liquid seal itself has been lost. And the solution is quite simple. In fact, it is swimmingly simple. All that we need to do is to redesign those fill pipes, remove those holes which we have seen, and the problem would be completely solved. Because then the vapor here cannot get back, because this liquid will act as a seal. The vapor can get into this pipe only if it goes to dead bottom, which of course we do not avoid. With that, I hope I have been able to convince you with my findings. Thank you very much. If the managing committee has any questions about my presentation, it will be my pleasure to answer those.
I have one. You said in the house toilets, you mean there are chances of exploding also?
No. Well, technically, yes.
Yes, technically, yes.
Just suppose, we call it an S drive in the toilet.
Yeah, that's why they have the break off.
That serves multiple purposes. One, it prevents vapor. In
Right.
fact, the sewage vapor is actually explosive and poisonous also. It causes a stink, it can kill you with the poisonous gases, and it is actually combustible. So it is a danger. The second reason why it is there, apart from the bad odor and the explosion possibilities, it also prevents rats and such stuff from coming back in. Any other questions?
These are mainly on petrol stations, not the diesel.
Diesel is less combustible than petrol. Therefore, we have not experienced the diesel lines. But in theory, the same situation happens. Diesel does not vaporize as much as petrol does. So in the tank, the vapor space has less pressure. The diesel pressure is almost negligible. Whereas in the case of petrol, the pressure in the vapor space goes up to around 0.6 bar, which is roughly, very roughly around 1/4 of the pressure you would fill in a small car tank, just to give you a feel of it.
What precaution actually is being taken by the here maybe airline distribution is the
I have not been able to hear you.
what precaution is being taken now? Because one we know the mobile calling over mobile is banned at stations.
Switch off the vehicles.
That's very true. But this particular case, this
Different.
point is not accessible to the customers. Only they are exposed to.
Okay.
And there the precautions are, one is to earth the tanker before the commencement of the operation. You connect an electrical wire between the tanker and the earth point to ensure that to minimize the possibility of static discharge. That's one of the precautions we do. And the second precaution, based on my findings, which I have presented before the managing committee, is to redesign these petrol pumps, remove those fill points, and take those fill pipes without perforations. These things are the cause of our problem, which is cost us a lot of loss, danger, and loss of reputation to the company.
But the PVC pipe is still there in the design? Or
The PVC pipe problem is still there. We are trying to see how we can improve our lane technology so that it does not happen subsequently. But initial days, there's no sag. It's after a few years, there's a little bit of soil settlement in the sag type piece. We have two recommendations for that. One is to replace a steel pipe like in the old days and give it a proper coating to protect it from rusting. And the second is to have thorough compaction of the bottom layer of the soil so that not to be any settlement. I am very thankful to all of you for having accepted my report. And if there are any more questions, I am at your call at any time. Thank you very much. We made it for this meeting.